David Needham, a well-known cancer researcher and now inventor of a new nasal spray that has potential to be a game changer for COVID-19 prevention and early treatment once it's tested. David is a professor in the Department of Mechanical Engineering and Materials Science School of Engineering at Duke University in the USA. He also has an appointment in the pharmacy school in Nottingham University in the United Kingdom. And he has held one of the most prestigious awards in Denmark as a Danish National Research Foundation Niels Bohr Professor at the University of Southern Denmark from 2013 to 2018. Originally from Oldham near Manchester, he is actually a chemist by training with a PhD in physical chemistry, researching gas-solid catalysis at the University of Nottingham, graduating in 1981. Following his mother's bout with breast cancer in 1972 during his PhD, he decided that he wanted to work in cancer research, and so he switched into the field of lipid bilayer and cell membranes during his postdoctoral training at the Physiological Laboratories in Cambridge University, United Kingdom, and then at the University of British Columbia in Vancouver, Canada, before being hired as an assistant professor at Duke University in 1987. During his 35 years at Duke, he has carried out fundamental research and has also applied his knowledge in cancer treatment, a thermally sensitive liposome drug carrier that releases its drug in the bloodstream of a tumor warmed by hypothermia treatment. More recently, he developed a new strategy for treating cancer following nature's designs and how cancer cells feed on the low-density lipoprotein nanoparticles from the bloodstream. We made a video of this back in 2019. He came up with a strategy that makes the drug look like the cancer's food. It was during this research that he switched to COVID-19 when it emerged in 2020. The pH dependence of nicotinamide solubility dissolution in morphology, motivation for potentially universal mucin penetrating nasal and throat sprays for COVID-19, its variants, and other viral infections. In the paper, he describes a new formulation that has the potential to prevent SARS-CoV-2 infection when used prophylactically as a preventive nasal spray. The same formulation could also be used in early treatment as a throat spray to help reduce the viral load that could otherwise go into the lungs. Let's hear about his new ideas and achievements. David, let's start by asking, how did you come up with the idea?
For the past several years, I've been working on new formulations for cancer, and one of the molecules that popped up as an interesting choice was niclosamide. Niclosamide has been used for 60 years as an anti-metabolic drug to treat parasitic infection, and basically, when taken as an oral tablet, it immobilizes the parasite in a person's gut by reducing its available energy, i.e., it reduces the amount of the main energy molecule called ATP that the parasite needs to do the work of maintaining itself in the infection. Like many drugs, niclosamide is not very water soluble, and so when it's taken in 2-gram quantities as 4 by 500 milligram tablets, it does not go into the systemic circulation. It's incredibly safe in that respect. In fact, toxic doses can be as high as 1 gram per kilogram, and so a person would have to take 70 grams to get acute diarrhea. So this almost complete lack of systemic toxicity is obviously good for its original application of treating the gut parasites, but it's relatively useless for it being used for anything else like cancer, where systemic delivery of the drug is required to reach the tumors. Anyway, back in March 2020, I was still researching niclosamide for cancer and a new project on lung fibrosis with one of my colleagues, Christina Barkauskas, who's a doctor in the Division of Pulmonary Medicine. She sent me a paper that had just been published in South Korea that showed niclosamide could actually stop viral replication in cells at only 1 micromolar concentration. So immediately I started working on it and seeing if I could make formulations that might be a nasal spray to perhaps act as a prophylactic, preventative, or throat spray that would halt the viral spread down the back of the throat into the lungs where it starts to do its most damage. My first idea was to go to the local pharmacy at the grocery store and buy commercially available nasal and oral solutions like nasal hydrating sprays, mouthwash, and see if I could dissolve or at least see how niclosamide would behave when added to these commercial solutions. My idea was that if I could make a formulation in something that was already commercially available, then the companies that make them would simply add niclosamide, test it, and will be able to manufacture and distribute it worldwide. I worked night and day on my own in the lab because our campus had been shut down. I made a series of formulations in hydrating nasal sprays, mouthwashes, and even eye drops. And I wrote a series of provisional patent applications and sent them to my Office of Licensing and Ventures at Duke, expecting them to follow up quickly in the face of this pandemic. But at the time, back in April 2020, there were only 65,000 cases of COVID-19 worldwide. I wanted them to help bring the ideas to a series of partners like Procter & Gamble, Johnson & Johnson, and Merck, but unfortunately the Duke office was not successful. So then I was on my own, and eventually Duke assigned back my invention to me in February 2021, and now I'm developing it myself. I nevertheless carried out researching niclosamide and thinking how best to formulate it for nasal and throat sprays. I'd read up on the physiology of the nose and throat, and it became clear that any microparticle formulation would not be that effective because microparticles can't actually get through the protective layer of mucin that covers the nasal and respiratory surfaces. Anyway, by studying the physical and chemical properties of this molecule, I figured out that I could simply dissolve niclosamide in a series of higher pH solutions of pH 8 and get a concentration that was 20 to 30 times that required by the Korean researchers in their cell studies to stop the virus in its tracks. So that's when I came up with the current niclosamide solution formulation that is now described in the paper I published in Springer Nature's journal, Pharmaceutical Research.
So how would it work? What is the mechanism whereby it stops the virus from replicating?
So niclosamide is a very interesting molecule because it can partition into lipid membranes of cells and especially into the energy-producing parts of the cell called the mitochondria, where it can inhibit the production of the cell's most important energy molecule, adenosine triphosphate, or ATP for short. Since ATP is critical in many cellular pathways that the cell uses to function and stay alive, niclosamide's unusual in that respect because it acts at a very fundamental level in the cell that is upstream from almost all of its processes. In cancer, it seems to act on those mitochondria in such a way that the cancer cell is in such trouble that it actually commits its own suicide, while normal cells don't seem to make this decision so readily and are somewhat protected. So the way it works in reducing viral replication is not on the virus itself, but on the cell that gets infected, i.e. the host cell in your nose and or throat. Turns out that in order to replicate, the virus actually needs to use the cell's own machinery. And so if the cell has already been exposed to an amount of niclosamide that reduces the amount of energy available, then the virus just can't replicate. And so that's what they found in the South Korean paper in their studies. At just 1 micromole of niclosamide solution concentration, viral replication was stopped 100%. So this mechanism, as I call it, turning down the dimmer switch on the cell, puts the virus itself in lockdown. And there seems to be other mechanisms that niclosamide causes. It could stop the virus infecting the nasal cells in the first place, i.e. it can stop the virus from getting its RNA into the cell. And it even affects the making of new competent viral particles. One hypothesis to be tested here is that these non-competent virions, if they're secreted into the nasal cavity, might actually act as their own vaccine for the local immune cells to pick up. There are actually 6 stages to viral infection, and niclosamide actually stops 3 of them, which is amazing and why I think it needs to be tested.
How would it be used, and what would be the advantages?
From everything we've seen in the literature, going back a good 10 years on other viruses and now SARS-CoV-2, and from everything we've done up to now in our own research, it would appear that the low concentration that's in the niclosamide spray is very safe to nasal epithelial cells. As we test it, I expect it to be used as a prophylactic preventative, sprayed up the nose from a spray bottle before a person enters into any high-risk environment like a store or other indoor gathering. When used in other mitigation strategies like wearing a mask, it would be added protection behind the mask, especially nowadays with such an actively infectious variant like Omicron. Recent studies in Christina's lab with her senior scientist, Zach Keller, are showing that niclosamide solution, just in a simple buffer, can start to act on cells in a matter of minutes. And so a person could simply squirt a spray of the solution up each nostril just before going into any high-risk environment, and the niclosamide will be there to protect them if they were exposed to any virus in the air. So the idea and the advantage is that if any virus got through to the nasal epithelial cells, it could perhaps stop the initial infection in the first place by stopping the virus from getting its RNA into a cell. And then if the cells did get infected, it could eliminate or at least slow down any viral replication, such that the immune cells activated by vaccines might be able to handle a reduced viral load. In early infection, it seems that the virus replicates in the nose and then travels in mucus secretions down the back of the throat into the lungs, and this occurs especially while a person's asleep. And so here, I envisage using what could perhaps be a higher concentration of niclosamide solution spread at the back of the throat to catch the cells and the virus that is heading towards the lungs, again, where it does its most damage. I therefore see all this as an additional layer of protection in the so-called Swiss cheese model, where multiple layers are required to initially prevent infection as much as possible, like from distancing to masking to washing hands, with niclosa spray being, as I said, added protection behind the mask. As this preventative and early treatment, it could be a ubiquitous add-on to all other strategies, including, of course, vaccines, antiviral pills, and antibodies that people think could even escape the new viruses. Since the leadership, at least in the USA, is saying we will have to learn to live with the coronavirus and COVID-19, niclosa spray could really start to come into its own as an additional mitigation strategy, not only for unvaccinated people, but also the vaccinated when the virus mutations again escape current vaccine control. Of course, that all remains to be tested, and that's why I'm looking for the right partners to take this on.
Speaking of that, what do you need for the next steps, and who would you like to engage and partner with?
As you probably know, every medication has to be tested in animals first, and then in humans, and determined to be safe. If it works, and does indeed provide some level of protection and reduction in initial infection, and or reduces viral replication, the simple niclosamide solution will be manufactured under stringent conditions. And we already have a protocol here worked out for sterile production within the Duke Compounding Pharmacy. It's filled into spray bottles, distributed and made available to the people of the world. It's my belief that people should not be making huge profits out of other people's suffering. And so I would like to find partners that share this view. For example, governments and infectious disease institutes that would have the resources and wherewithal to take this on and offer it at cost, or reduced and reinvested profit, with some of that profit going towards the further development of semi-cancer formulations, which would then be similarly tested. Basically, open source pharmaceuticals starting generic. We actually do have a small grant from the American Lung Association with Christina, but things need to move much faster than we have the resources and expertise to accomplish. So with the paper published and the patent application file on how to make and provide what could be a very simple nasal spray preventative and early treatment throat spray, I'm now looking for such government labs and infectious disease institutes where they have access to the latest viral variants and the resources to conduct clinical trials in humans, to start this testing and bring it through the manufacturing and distribution process to in their own countries. In late-breaking news, we have actually made contact with the National Institute of Allergy and Infectious Disease. That's Tony Fauci's own institute. And they put us in touch with the respiratory disease branch, who could actually do the initial testing in their contracted animal models for coronavirus infection. So this past week, we've just filled out a large 50-page production information sheet for SARS-CoV-2. It's a request to the Institute, and we'll submit that, and hopefully the niclosamide solution can be tested to see if it shows promise in this infectious disease animal model. So that's a step forward. As I've discovered by researching the literature, niclosamide could also do the same for many other respiratory viruses, and one that the person at the respiratory diseases branch is interested in is respiratory syncytial virus, or RSV. And as the CDC says, RSV is a common respiratory virus that usually causes mild cold-like symptoms. Most people recover in a week or two, but RSV can be serious, especially for infants and older adults. RSV is the most common cause of bronchiolitis, that's inflammation of the small airways in the lungs, and pneumonia in children younger than 1 year of age in the United States. And so she says they have nothing for these tragic at-risk infants. So I hope we can work with her and her team and help in this regard too. Anyway, once established for COVID-19, it could find applications across the world for this and other viral infections, and indeed new ones that might arise. It's my gift to a suffering world.